We finally get a launch date for the Space Launch System, the strongest magnet in the universe, more amazing images from James Webb, and we've got a launch provider for the Nancy Grace Roman Telescope. Hi everyone, I'm Fraser Cain. I'm the publisher of Universe Today, and this is our Space Bites segment. Now, this is just a shorter version of my much longer weekly email newsletter that you can sign up for, and I write it, but we understand not everybody wants to read the news. Some of you like to have the news videoed at you. So let's get into the news. More pictures from James Webb. A lot of you have been asking me when we're going to see the next pictures from James Webb, and the answer is all the time, nonstop. There will be more and more pictures. We've got, for the next 20 years, there's going to be pictures. And the reality is that we're not going to be seeing these giant big releases from NASA celebrating the Space Telescope that often, unless something really exciting happens. Instead, what you've got is researchers getting time with James Webb, pulling down their images. A lot of those images are being immediately available on the internet so that you can look through them, and various image experts can take those images and try to produce some very beautiful pictures from them. And so the first example that came out was a galaxy called M74. And this is a fairly famous galaxy. It's one of the Messier objects. You can see it with the telescope. And here's what it looks like from the Hubble Space Telescope. And here's what it looks like in James Webb. Now, this is a scientific image. This was gathered by scientists because they wanted to do research on star formation in this galaxy. They used 4 separate filters and gathered all this data and put it on the James Webb data archive. And one of my favorite astro image processors, a woman named Judy Schmidt, took these images and made this incredible image. And it's hard to describe. It's like some kind of spiral, some kind of eldritch portal to another dimension, but it really just shows a different face of M74, but at a much higher level of detail than even Hubble was capable of doing. And this isn't the only picture that we've seen come out. We've got an image of a galaxy, and it just looks like a red blob, but it happens to be the most distant galaxy that we have ever seen. So the galaxy is called Glass Z13. Now, the glass is the survey that's being done, and the Z13, that is the redshift number of this galaxy. And if you don't calculate redshift numbers in your head, that's no problem. Z13 roughly equates to seeing this galaxy as it looked about 300 million years after the Big Bang. And this is just one of the first galaxy pictures that were taken by Webb. You know, we're still in the first few months of science operations, and yet we're seeing this galaxy. It probably has about 1 billion stars in it. And when you compare that to the Milky Way with about 100 billion stars, it's still much smaller than the Milky Way. And yet it's a surprisingly large object that has come together only 300 million years after the Big Bang. Think about it, right? You had all of these clouds of gas left over from the universe, and then these had to come together to form the first stars, and the first stars had to come together to form the first galaxies. And yet, only 300 million years after the Big Bang, we are seeing this galaxy. And this is definitely not the best that Webb can do. This is just one scientific observation, one interesting red galaxy in this giant observation. We're going to see much longer observations done, ones which are going to rival the kinds of time frames that we saw with the Hubble Deep Field, and yet done with James Webb, which is many times more powerful. We're also going to see gravitational lensing, where we see some foreground object that is lensing more distant galaxies and magnifying them by factors of 10,000 plus. So this record of the most distant galaxy that's ever been seen is going to be broken anytime now. But don't forget about Hubble. It's still taking some amazing pictures. And here's a really cool picture taken of the Tarantula Nebula. You've got 2 separate star-forming regions in the Tarantula Nebula. And this is a recent image by Hubble that can show just how the 2 nebulae are so different, and yet they're side by side in the sky. We've got a lot of updates coming from NASA. The first update is that we finally get a launch date for the Space Launch System. NASA held a press conference this week, and they gave us a firm-ish date for when they think the Space Launch System is going to launch. August 29th. The plan is that Space Launch System will launch on August 29th, carrying the Orion capsule into a lunar orbit. It's going to go into orbit around the moon for several weeks, and then it's going to return. We should see it back on Earth around October the 10th. So we'll spend about 42 days in orbit. That's just the first date that they proposed. They suggested another couple of launch windows could open up if weather causes delays, one for September the 2nd and another for September the 5th. So if all goes well, in just a few weeks' time, we should see the Space Launch System, one of the most powerful rockets ever built, blast off. And of course, this is the first step of NASA's return to the moon. If Artemis I is successful, we could see the first crewed launch happen in 2025. So stay tuned. We also learned that the upcoming Nancy Grace Roman telescope is going to be launching on a SpaceX Falcon Heavy. This is really the first time that we've seen a science mission for NASA due for launch on a Falcon Heavy. There's been a couple of other missions that have been proposed, but we're going to get into that in a second. So if all goes well, Nancy Grace Roman will launch on this Falcon Heavy in 2026. Now, what's interesting is that on the SpaceX website, and for the longest time, the price of launching on a Falcon Heavy rocket was $90 million, while, say, a Falcon 9 was $60 million. So it's a big cost savings compared to other traditional launch systems. But NASA announced that they're paying $225 million for this launch on the Falcon Heavy. So I guess the Falcon Heavies are not as inexpensive as we were originally led to believe. Now, what's great about Nancy Grace Roman, this is a Hubble Space Telescope class observatory. It is roughly the same size as the Hubble Space Telescope, but has a much wider field of view. And its primary job is to help map out the amounts of dark energy and dark matter in the universe. Right now, we have very rough estimates for how much of the universe are taken up by dark matter and dark energy. When Nancy Grace Roman launches, we should get much more precise information and really get an answer to that final question: will the universe tear itself apart in the future with the Big Rip? Wait for Nancy Grace Roman to give us that answer. NASA's Viper rover is getting delayed to 2024. So the Viper mission, this is a rover lander that's going to be going to the moon's south pole. It was originally scheduled to be going in 2023, and NASA decided to push that launch back to 2024. They wanted to spend more time with testing the hardware, the software, the landing system. And so they decided to shift that launch window back. And that's a really good idea because recently we saw a couple of landing failures from two nations attempting to land on the moon. Israel had a problem with their lander on the moon, and India's Chandrayaan-2 had a problem with its landing. So the moon is actually a very difficult place to land on, and so to spend a little more time testing probably makes sense. Of course, the Chinese had no problem with their various landings on the moon. So sometimes it can be simple, sometimes it can be difficult. We've been talking a lot about the Psyche mission, and now we've learned that it's needing to go through a very extensive review. Psyche was a NASA mission that was going to be going to this really cool metal asteroid. And to be honest, this is one of the missions this year that I'm most excited about. And we learned that the launch had gotten delayed because of some issues with the software that had been developed. And what we're learning now is that the software is needing a lot more testing to get it prepared for launch. It sounds like the situation wasn't really well understood by the managers involved. And so NASA's decided to do a very detailed review to really understand what is the state of the mission, where did the problems creep in, who didn't know what when, and hopefully they'll be able to get a sense of whether or not the mission can launch. But one of the things they said is that this launch may never happen. The mission may be canceled if it's gone so off the rails. So hopefully it's not that bad, and we'll see a mission sometime in the next couple of years. Perseverance found some string on Mars. So look at this picture. You're looking at a weird little stringy object. And this is something that NASA's Perseverance rover found on the surface of Mars. What is it? I mean, it does not look like the kind of thing you would find on Mars. The answer is we don't know. but most likely it is a piece of the Perseverance rover, either from its parachute, from its back shell, from its descent equipment, and at some point it fell onto the surface of Mars and blew by the wind in front of Perseverance, which I know kind of sounds like quite a big coincidence. And we know that the wind blew it there, and then in another picture, it's gone. So the wind had blown it away again. So yeah, I mean, maybe it's a really bizarre Martian life form. I would not guess that's the case. I would mostly suspect it is a piece of debris left over from the spacecraft. How to capture near-Earth asteroids. Saw a really cool study. You actually reported on this on Universe Today this week. It's an idea to essentially minimize the risk of near-Earth asteroids and create a lot of resources that future space exploration can use. And so we know that we are in this cosmic shooting gallery. There's about 30,000 asteroids, near-Earth asteroids, that come relatively close to the Earth, some which will have a potential to crash into the Earth into the future. It's not a matter of if, it's a question of when. And so one of the best ideas that we have is to try and take all of these asteroids and make them safe, push them into much more usable orbits. So the idea in this paper is that you set up two spacecraft, one which is the pitcher and one that is the catcher. And so the pitcher spacecraft flies from asteroid to asteroid and jumps off of the surface of the asteroid, imparting a kick that changes its orbit slightly. It then is moving through space into its new orbit, and then the catching spacecraft does its jump off the surface of the asteroid and puts it into a final orbit that is a lot safer and more useful for us to extract the resources off. And what's cool is that the two spacecraft can just go jumping from asteroid to asteroid and change a whole bunch of asteroids all at the same time without having to burn a lot of fuel. And it's a very efficient way. They've calculated that you can use your fuel to be able to shift the orbits of many asteroids for a fraction of the price of what it would cost to just do one asteroid at a time. It's a really clever idea. Astronomers find the strongest magnet in the universe. Astronomers were using the Chinese InSight HXMT X-ray telescope, and they were observing a pulsar that seemed to have a binary companion. And it turns out this binary companion was a magnetar that shifted through this accretion disk of material surrounding the pulsar. And when it did, it blasted out this burst of X-ray radiation. And based on that burst of X-ray radiation, the astronomers were able to calculate the magnetic field of the magnetar. And what they found was that it is 1.6 billion Tesla. And if you don't know what that number is, and I had to look it up as well, it's a million billion times the magnetic field of the Earth. And it is the strongest magnetic field that's ever been seen in the universe so far. Astronomers find a dormant black hole in a nearby galaxy. Astronomers know about lots of black holes, but they tend to have the same kinds of characteristics. Either they are a supermassive black hole that is located at the heart of a galaxy like the Milky Way, like Andromeda, like M87, and they are obvious based on the gravitational interactions that they have with their surroundings. If they're actively feeding quasars, then we can see these bursts of radiation coming out of them. The other way that astronomers find black holes is if they're in some kind of gravitational dance with a binary object. This is a stellar mass black hole, but they have to be close enough that the black hole is like actively feeding or somehow interacting with this other star, and so it is releasing radiation that can be detected. But astronomers have found a black hole that is dormant, so it's not giving off actively any radiation. They're able to detect it purely through its interactions of gravity with the star that it's orbiting around with. So the black hole has probably 9 times the mass of the sun, and it's orbiting around a star that is 25 times the mass of the sun. And they're located in the Large Magellanic Cloud. And this was found through a survey of about 1,000 separate stars in this one big image. Astronomers were carefully studying it, and they were able to pick out the gravitational interactions between this black hole and the star, even though the black hole isn't feeding right now. It's Dormant. If you want any more information on all of the news stories that we talked about today, we're going to have links in the show notes down below. And I cover most of these stories in my weekly email newsletter that comes out every Friday. So if you want to get that, go to universetoday.com/newsletter to sign up. I write the whole thing. It's completely free. There's no ads. Join the 50,000 other people who read this newsletter every week. And if you want to listen to our audio, why don't you sign up to our podcast? Just go to universetoday.com/podcast or just search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. Thank you to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, the galaxy wanderers, and a special thanks to Andrew M. Gross, who supports us at the Master of the Universe level. Your support means the universe to us. All right, those were all the stories that we had this week. Thanks, everyone, and we'll see you next week.